Constructing the pier is the most important part of a astronomical observatory. The reason is that this pier will support the mount and thus the telescope. So initially, I wasn't sure what to do, so I just created the pavement from cement, and now I plan on adding a cemented pillar, and to do that, to fix it to the ground and to avoid it from falling or even vibrating, I am doing the following. I will fix these two metal rods in the concrete, and then I will insert this tube here, and as you can see, the two metal rods, one of them is already there, the other one is not, but the hole for it are already in, and there is another rod going from one side to the other, and these will be fixed. So I will use these bolts, special bolts for fixing things in the concrete. So those go in, and then you screw them in place, and this goes here and it inflates it. So basically you won't be able to pull it out, or you won't be able to move, thus fixing this pillar. So the plan is to pour cement in this pillar. So this is a regular tube used for sewage, 200 millimeters in diameter, and it's 1 meter high. A little bit too short for my taste. I have another one, and I will cut that in half, and effectively getting a 1.5 meter high pier. So somewhere around here, and I will place my mount adapter, which is produced by Lacerda, in the cement, and I will effectively get something around this level, and the mount will be positioned on top with a scope parked horizontally. So in this way, I'm hoping that by fixing it to the ground and also cementing it and using these metal rods, inserted both in the ground and in the cement, to get a sturdy pier. I chose the 200 centimeter tube because this is exactly the design for the Lacerda pier. So right now it's all in position. You can see this is where I will insert this, and another one for the second one. These are the same kind of things I have used for the structure. As you can see here, the structure fixed. There are 4 of these in each corner, and also for the 2 exterior wooden pillars supporting the frame, the extension for the roof. So now I will show you how you put this in the cement and fix it. So secure it. So the idea is, as you can see, when you start screwing this, these expand because of this. So this is exactly what we will be doing, and I will use a hammer to insert this, and then I will use this key So in my case it's a 10 millimeter for this, to rotate this and secure it in place. And basically what you do, you keep rotating till you cannot, till it gets stuck, and that tells you that it's fully expanded and you can no longer push it further. So let's do it. Okay. Okay, it's getting harder. More and more difficult to rotate. Alright, now it's fully fixed. Nothing will move this guy from its position. And I will do the same thing with the second one here. So let's just put this guy here, the camera here, and what's normally good practice is to check that this is balanced. So let's check now that the whole thing is balanced. Well, it should be balanced because the floor is balanced. This sits on the floor and should be balanced if the base of the tube is flat. So let's just give it a try. Alright, balanced in this direction. Usually you do it in two perpendicular directions just to be sure. See, it's balanced. So I've done the same thing with the second one. It's secured here, and it's a good thing to do it before you secure the future pier, but I already did that, but now I'm just going to show you. You check that it's leveled by measuring its level in two perpendicular directions. Now this should be the case if the guys that poured the concrete floor did a good job. It should be flat, and also if the tube has been cut properly, it also should be perfectly horizontal. So as you can see inside, there is the metal rod going from one side to the other, and the two vertical rods inserted in the cement. So this should firmly fix it. The vertical rods go in the cement, and then they also go way up about this. They're about 37 centimeters in total. About 10 centimeters are in the concrete, and the rest goes all the way maybe here, and this goes from one side to the other. Now you can imagine, once I start pouring concrete here, everything will be cemented, and I will go all the way up. Once I reach this level, I will insert the second tube, which I cut so that the height is at about, the total height is at about 1.5 meters, plus the Lacerta adapter, metal adapter, that will be inserted in the concrete. So hoping this will make a nice video of the entire process. Now you can always adjust these here to squeeze it further, but in this case I don't think it's needed. I was initially thinking of using an additional here and here. Now the problem is that when I bought these are of the same size, so I won't be able to insert another rod because it will hit this one. So I should have bought a taller one and inserted the rod here. But nonetheless, I don't think that this will cause any problems because I will cement the vertical rods and this in place, and these are already fixed in the ground here. Another thing that I would like to tell you is that this is right in the center of the whole thing. So it has at least 9, it's about in the center because it has between 91 and 92 centimeters from this side, so from the sides of the tube to the OSB board. So I have plenty of room here to maneuver the whole telescope. So as I said, the plan is I will start making the concrete. I will use cement and a mix of sand and stones, ratio 1:3, so one shovel of cement and 3 shovels of a mix of sand and stones, small stones, and I will start pouring them inside. Once I get about this level, I won't let it fill up. I will insert the other tube, which I'll cut, and then I'll continue pouring. I won't fill the whole thing all the way up. The reason is that I'll need to insert the Lacerta mount adapter for the EQ6, EQ8. So I bought the EQ6, EQ8, even if I don't have a mount yet. But it's I have an EQ5, but I plan on getting an EQ6. So once once you start inserting the metal parts of the Lacerta adapter, obviously the extra mass will push up the level of the concrete up. So you don't want to fill everything all the way up. You want to keep it a little bit below. I'm not sure how much because I haven't done this before. So I will leave maybe, I will fill it with cement maybe up till here, and then I will insert the adapter. Now the adapter sits perfectly in this 200 centimeter tube. It's like it was designed for something like this. Now you may ask, what will I do with this after I've poured the concrete? Well, I will leave it here. I won't do anything. This will remain in place. I won't smash it, take it out or anything. This is why I secured it on the sides with that, and then this is also why I had this metal rod going from one side to the other in here. Anyways, you won't be able to smash it once the cement solidifies and makes contact with the plastic tube. It is going to get messy, and there is no reason why you would want to do that. Another thing that's nice for this tube, this is a sewage tube. Actually, people use these in their houses to eliminate for the drainage, for the sewage system. Is that this part which gets inserted into the next one is wider, So basically when the cement gets here, it's not, doesn't have the same width all over the place. Here it will be thicker at the base, and this is actually a good thing, because being thicker at the base gives it an extra the extra stability that you may look for when designing these things. Alright, so yesterday we have poured some concrete inside. Now it's completely solidified, and the idea is to add this additional extension tube to this one. This is a 1 meter tube, and I'm going to insert this additional 60 centimeter tube. It's 50 plus this part here that's going to go all the way till this point. So it's going to give us a pier 1.5 meters high, and once I cement this, I will insert the adapter, and this is the adapter that's going to be inside the cement. So this one here has 9 kilograms, and this is going to go like this. So basically, once I pour the cement, I'm going to stick this one inside the cement all the way here. It's going to stay like this. It's a perfect fit, basically. So this is, and the mount will be here. It's gonna be inserted here. Let's try the same here. Let's see if this gives us the same result. So put it here, and yes, it's a little bit. This is because you make it horizontal by rotating these screws here. So we can do this after we pour the cement. So at the end, this is what we will get, just a little bit higher on this tube. So this is the EQ6 adapter, and the telescope will sit on this thing here. Alright, so we have continued filling this tube with concrete, and we are almost all the way up. Now I want to insert this one before we continue. So as you can see, we've got it all the way up almost. Now I would like to insert the one that I cut, but I want to take these out first, and just good. I don't have a soft hammer, so I will be using this instead, like this. Does look a little bit tilted, but I think it's just my impression, isn't it? Okay, that's more like it. Let's measure it again. Okay. Okay. Excellent. And see. 156. All right. So let's hope this one will fit in here. Will it fit? Yes, perfect. Goes in. Or if it doesn't fit, I'll just open the roof, roll the roof, and continue. All right. Let's see how this one looks inside. Let me illuminate it a bit. See, it's all the way in. And now let us continue. So there aren't any infiltrations here. There was no cement from yesterday. Just water, as I said. So let's continue. Pier is fully cemented. If we take a look inside, you see it's all the way up till here. Now I do not go any further because we need to insert this piece of metal, this device. It actually looks kind of cool. It's like inserting the warp nacelle in the warp drive. Okay, so the specs say that it should be 2/3 in, and from here up here it should be outside. So this from here to here should be 2/3 from the entire length, which is 1/2 meter. So once we put this in, and if we do it in the wrong way, it's gone. I mean, we cannot reuse this. Now ideally these two should point south north. I have a compass. I know for a fact that north is that way. So the whole garden is lined north-south, and I also have a compass. When using it, pay attention, you must include the magnetic declination. So let us introduce this into the concrete. This is going to be very interesting, and let's start. Oh yes, it's actually kind of cool if you think about it. Right now it actually stays inside the cement, so if you can have a look inside and try to illuminate a bit, you can see it's actually fixed in the cement. Nothing will move this once this solidifies, even in the morning. It's actually cool. It's like installing a warp drive. You need to push it all the way in. All right, a little bit more. And this is it. It is in the, rotate it a bit. Right now it's in the cement fully, and let's double check. Let's rotate this a bit till it faces approximately the north, and there it is. This is the pier. So we need to double check that this is completely horizontal. You can always do this by adjusting the knots here. Let's do that now. Okay, and the other way around. Yes, so you can see if you have a look, if you take a look here, this is perfectly horizontal, this direction. Now we need to adjust it a bit here. So we need to see, it starts to level up. Now it's fine. Right, just tighten the screws a bit so that they stay. Let's double check this side as well. All right, we need to adjust this one a bit. This is leveled, the mount is leveled. That's it. So now it's fully cemented. It can now receive the telescope.